क्या दिखाना है क्या उसमें? हेलो। मैं कह रहा हूँ दिखाना है क्या, ज्वाइन तो है हम इसमें। हाँ। अ- अच्छा। ठीक है ना, कोई दिक्कत हो तो बता देना, फिर ये एंगल चेंज कर दूंगा इसका। माइक टेक करना। हेलो हेलो, माइक आ रही है आवाज? हेलो हेलो। ठीक है।
Good evening, everyone. Hopefully, I'm audible. So, let me introduce Dr. Anna. She will be presenting her PPTs first. So, let me just formally introduce you. It's a pleasure to welcome Dr. Anna, a distinguished researcher, academic and technology leader working at the intersection of science and technology, international operation, and digital transformation. Dr. Anna is the CEO of Coordination Lab and associate professor at St. Petersburg State University and a leading research fellow at HSE University, Center for Comprehensive European and International Studies. She is also an expert with the BRICS Russia Expert Council in the SCI sector and a member of the WTO ESDA working group. Today, she will speak on women in critical technologies, from W20 to a BRICS agenda for AI and digital sovereignty, exploring the important role of women in shaping the future of artificial intelligence, cybersecurity, and other critical technologies. Her presentation brings together questions of innovation, inclusion, and digital sovereignty, and examines how international cooperation with BRICS can create greater opportunities for women in technology. So, big hand of claps for Dr. Anna.
Namaste. Okay. So, what? So, good afternoon, everyone.
I would like to formally felicitate you.
Okay.
Before you start with your formal presentation.
Before this,
Yeah.
maybe after, or you will not like my presentation.
No, we'll certainly like your presentation. A lot of for our guest, Dr. Anna. Thank you so much. So, maybe the photograph आगे और लेनी है pictures. चलिए आइए आना एक one more photograph. We keep it here.
So first of all, thank you, Professor Beth Joshi, dear colleagues, and everyone for having us here. It's a great pleasure to be in New Delhi, in India. And congratulations, everyone, studying in such a great place. So, to begin with, artificial intelligence is moving from being simply another digital technology to becoming basic economic infrastructure. Cybersecurity, and I know that you have a Center of Cybersecurity here, is no longer a narrow technical specialization. Semiconductors have become the subject of international politics. Data centers are increasingly treated as strategic infrastructure. Energy policy and AI policy are beginning to overlap with each other. And of course, some of the jobs that will be completely normal when you graduate probably don't even have names yet. So I don't want this lecture to be simply about women in technology. I want to talk about something larger. Who builds technology? Who controls critical layers? And who receives the value from creating it? And why women should not become just simply users, but researchers, engineers, and decision makers. So I lead Collaboratoria, among other affiliations that you already heard. It is coordination lab in Russia. Collaboratorium or coordination lab brings together researchers and experts working on international relations, artificial intelligence, digital transformation, and digital research methods. And one of our projects that I want to share with you today is a living textbook. It is called Research in International Relations, Applied Methods, and Digital Tools. And after the lecture, I will also give you a QR code so you can screen and look at it. It is in English. So our lecture today will be connected to a larger idea that in technology, education cannot be just in one textbook. It should be alive. And today we also are going to experiment a little. I want you to participate in a live quiz during a lecture. So please screen the QR code you see here. And there will be questions throughout the lecture. You will receive each of you points for the correct and speed answer. And I should tell an important thing in advance that whoever finishes first today, you will get a small prize to me from St. Petersburg. So this is not a lecture, this is competition. So now have everyone screened it? Yes, so I can start. Yes? So now we can launch presentation. You see the first question? So you have 20 seconds left, and I will begin with the presentation. So this is the slide about coordination lab that I already talked about. I'd also show this work after the lecture, so you don't need to. Okay, we have 33 right answers. That's great. Thank you very much. Yes, and this is our textbook. I also will repeat this work after the lecture. So this was the first question. You already answered it. And now I will a bit touch on this issue. So what is G20, where I participate in Women's School of Technology? The G20 brings together the world's major developed and emerging economies. This is also the system of engagement groups represent business, think tanks, young people, women, and other communities. So one of them is Women 20, W20. And now for many years, a major part of digital agenda was focused on access to the internet, access to devices, access to education, access to financial services, access to digital skills. And these issues are still important. But something has changed. And in 2025, W20 recommendations that we made already went considerably further. So we called for targeted scholarships for women in high-growth STEM fields, including AI, women participation in AI development and decision-making. And also we called on creating a special index, international index, which is called the Global Index on AI and Gender Equality. So I think we are moving now through 5 stages that You see this, but not all of them, but I will name them. So first is access, second is skills, third is participation, fourth is leadership, and fifth is ownership. So what does mean access? It means I can use technology. Skills means that I understand technology. Participation means that I can work in technology. And leadership means that I can decide which technologies are developed and how. And ownership means that I can create a company, own intellectual property, lead a laboratory, control investments, and participate in it. So we are coming to the second question of our quiz. So please, you have 30 seconds to answer. Women represent about 41% of the global workforce. So what share of the global science, technology, and mathematics workforce do they represent? 18%, 28%, 39%, and percent. Okay, most of you answered that 18%. Correct answer is approximately 28%. So you see that there is this access gap. Globally, you see women represent 41%, but workforce only 28%. This is a problem. And UNESCO also represents women make up only about 35% of STEM graduates globally. So this proportion has been barely changed over the last decades. And there is even a more interesting pattern that women increasingly enter technology education. They increasingly use generative AI. But this does not automatically translate into control over the highest value parts of technological system. So UNESCO latest work finds that women are more concentrated in data preparation and downstream AI services, and considerably less represented in model development, in where technical authority, intellectual property, and high value employment are concentrated. So Stanford 2026 AI Index okay. This was the question. Yes. Sorry. So this, the most popular index in the world about AI is Stanford AI Index. So 2026 results show that there is similar situation. So even countries with comparative high female representation among AI researchers and developers remain from parity. So female representation is around 32% in Saudi Arabia, 30% in Australia, and also around 30% in Canada. So no country in its dataset approaches 50-50 representation. So I would formulate the problem like this. So the access gap is beginning to shrink faster, then the power gap. Yes. So that matters because being present in technology is not the same thing as having influence on technology. And now the third question would be, 1 second, I will be this. Yes, now you can answer it. A global study of 133 AI systems found gender bias in approximately one share of them. 10%, 22%, 44%, or 75%. So most of you replied that 44%. So let's see the first statistic. Yes, that's right. Congratulations. So 44% of AI systems demonstrated gender bias, while 26 of them showed both gender and racial bias. So this doesn't mean that we must automatically build fair AI. And it certainly doesn't mean that men automatically build biased AI. A bias comes from training data, sampling, design choices, business incentives, deployment environments, and historical inequalities. So, or inappropriate assumptions about the difficult to use the system. But diverse participation changes something fundamental, the range of problems that teams notice. So let's imagine that recruitment model trained on 20 years of company hiring decisions. Technically, historical data may look like excellent training data, but if historically 85% of senior engineers of the company were men, then the system may learn patterns associated with this historical hierarchy process. So nobody needs a program that prefer men. And this pattern has emerged statistically. The same problem has appeared in healthcare, in relating, or insurance, and so on and so forth. Special recognition, yes, language technologies. So this is why responsible AI. Oh no. This is why responsible AI is not something like philosophers add to technology and engineers have finished building it. So it is a real part of engineers. So, and the next question will be, so here's the next question to the quiz. Which of these statements about today's leading AI systems is true? So if a model can solve advanced mathematics, can reliably perform all simple tasks, leading models can perform a gold medal level in mathematics while still failing surprisingly simple tasks. AI systems have already eliminated benchmark failures, or AI performance improves uniformly across all capabilities. So 20 seconds left. So most of you answered the second option. So let's see what is the So a strange thing about AI in 2026, and it is one of my favorite findings from Stanford AI Index 2026, that an advanced Gemini system reached gold medal level performance at the International Mathematical Olympiad. So at the same time, the best model tested on the reading canal box managed only about 50% risk. So AI engines also improved dramatically on tasks involving real computer interfaces from around 12% to 66% task success. but still fail approximately one of the three structure classes. So this phenomenon is sometimes called the jagged frontier of intelligence. It can be extraordinary and ridiculous in one time. And this is a very important lesson for the students. So never confuse impressive output with general reliability. And another figure is even more important. The Stanford Index reported 362 documented AI incidents in 2025, up from 233 in 2024. So you see that the amount of them are increasing all the time. So at the same time, reporting on responsible AI benchmarks remains much less systematic than reporting on capability benchmarks. So in other words, our ability to build AI is currently improving faster than our ability to understand its consequences. And we are coming to the fifth question of our quiz. So what share of notable frontier AI models in 2025 was produced by industry rather than academia? There's about 35%, about 55%, about 70%, more than 90%. So we have different answers. Most of you replied that about 70%. So actually, this is one of the greatest contradictions of AI revolution. AI is becoming widespread, incredibly widespread. So generative AI reached around 53% population adoption in one of these years, 53% of the world. So faster than either computer or internet. And organizational adoption around the world reached 88%. And 4 out of 5 university students now use generative AI. Who of you use generative AI? Please raise your hand. So yeah, I think it's around 90%. Probably another 10% is sleeping. So more than 90% of notable frontier models, and we are coming back to the question, 2025 were produced by industry, 90%. So US private AI investment reached $285 billion in 2025. This is a lot, pretty big. So, and geopolitical competition, and this is here where I came from, international politics, is changing very quickly. So the performance gap between leading US and Chinese models has effectively closed. Yes, and we talk about competition between our main powers, China and the United States. So they are now kind of the same level. And AI is simultaneously becoming more accessible to everyone, but more dependent on extraordinarily capital-intensive technological infrastructure. So that brings us to the cake. And let's see what is this cake. First, next quiz question. You know Jensen Huang is the head of India, the most expensive company in the world. So according to Jensen Huang, AI 5-layer cake, what is the bottom layer? What is the most base layer of AI? So most of you reply data. Sorry, but this is not true. So you can see it on the picture. On the picture, you don't see the first layer, but believe me, this is energy. So NVIDIA's here, Jensen Huang, offers a very useful way to understand artificial intelligence economy. Most people see AI on the top. ChatGPT, Gemini, Claude, DeepSeek. But Huang describes AI as 5-layer tree. So at the bottom, we have energy, above the chips, then infrastructure, which is data centers, networks, cooling, cloud infrastructure. Then we have models, and finally applications. So data is a part of this, actually, something between infrastructure models. Yes. So this is one of the most important diagrams for understanding the modern AI. Because it immediately tells us that AI is not just like software. It is extremely physical. It needs electricity, water, land, semiconductors, factories, networks, cooling systems, data centers, capitals. And what do you think actually is the most important for AI systems to evolve in the international competitions? Which of these? And it's a question for you, open question, not quiz. What is the most important for AI to develop?
Data.
Data, other version?
Can you repeat it?
Energy, other these answers. We have data, energy, probably semiconductors, yes. Or okay, I will tell you the truth because I speak a lot to people of top AI companies in different countries actually because of their construction. So the most important resource are human capital. Because without clever people who know how to train machine, it's not evolve. So the world competition is now going actually around people like you, how to hire the best, let's say, brains. And the problem is that the ones like countries, it's United States, China, have a lot of money to hire such people. So that's why it's a big issue. So, International Energy Agency now projects that electricity consumption from data centers could rise from roughly 485 terabytes in 2025 to around twice. So this is why AI strategy for countries is now becoming energy strategy. And this is also extraordinary concentration. So United States hosts around 5,500 data centers. So more than 10 times any country has. And only one company from Taiwan, TSMC, fabricates almost every leading AI chip. Now, think about women's careers through this cake. Women should not represent only top layer or consumers and applications. Yes, we should have women in energy, in advanced manufacturing, cloud infrastructure. All these layers are really important. So this is, I prefer the expression women in critical technologies and not only women in tech. This is the name of our lecture actually. So we come to the next question of our quiz. And this is, which definition best captures technological independence? Refusing all foreign technology, producing every component domestically regardless of cost, maintaining control over critical technological capabilities, and the ability to make meaningful choices while continuing international cooperation. And finally, disconnected national digital infrastructure from global networks. I will step over there for like last week. Still 15 seconds. So most of you replied right answer. Of course. In fact, how many times do you have left? How many times do you have? Oh, yeah. How many? 5 to 10. Okay. So what does it mean, technological independence? And we have a new Russian law about this. I will not stop here because probably you're not so interested in our internal politics. But I should say that, but it's fine, yes. But I should say that now almost each country has its own legislation on AI and on UK also developing. But all what we talk when we regulate AI, it is about technological independence. So this is a very important issue for all governments. So, and this is called, the concept is called technological sovereignty. So technological sovereignty means capacity to make meaningful technological choices. So the country should be able to understand a critical technology and to adapt it, to secure it, develop, both knows how it works and how to create it, to maintain critical functions, replace dependencies, and choose conditions under which you want to cooperate. If you were just yesterday, as it was, the United States introduced that their Pacifica, this is the alliance on AI, now means that each country wants to participate in their alliance, they could not choose any other country to cooperate, which not do this alliance. So this means even participating with, for example, India. You cannot cooperate with Russia, you cannot cooperate with any other countries of Southeast Asia, which are not in this Pacifica. So this is actually my sphere of competence. I looked through these processes in international politics, which I implicitly connected with AI, and trying to figure out what should we do to not to make this AI Cold War. So the next question is, which situation illustrates the concern behind AI colonialism? It is also a very important term for us. So that researchers from different countries, so now you can answer, sorry. Researchers from different countries jointly developing an AI model. Countries using both domestic and foreign software. One region supplies data, labor, energy, and resources, while technological intellectual property and most economic value remain concentrated elsewhere. And the last one, universities exchange with students. This is a very interesting option too. So 20 seconds. Yeah, you want to you reply correctly is the longest answer. So what does it mean, AI co-analysis? It is not universally accepted legal terminology, but if you remember this one case that I showed you, so this means that country could not provide any of these layers. So if it's even dependent on one layer, it means it is not independent. And of course, if it's dependent on another country, this is bad. So this is why we really need international cooperation. Because couldn't these maybe name the country which is dependent on all of the layers of this cake? China, other? China, USA, okay. Nobody names Russia or India. Actually, there is no such country in the world. No, because in the United States, there is a problem with critical minerals because a lot of them are, and we can talk after lecture, you will tell me the truth. But for example, China is dependent still on the best semiconductors. So it's, and what is important for us, most important thing, it is of course part of this AI colonialism, this data colonialism. And this means that more and more data is going to these AI giants, these chats, or ChatGPTs, DeepSeeks, and so on. So that's why now your country, my countries are building their own fundamental large language models. And this aspect is very important because we could have like simple large language model, small large language model, yes, but if the training process that kind of starts from like the basic level, it's not solid, so it is a problem for us. So in Russia we have totally fundamental LLMs. It's called Yandex, EcoChat, and I know that in Italy also this year there's some fundamental LLMs. So actually I've been to AI Impact Summit held here in Delhi and seen a lot of startups from here. So as I know that we are actually should be a bit in a hurry, let's go to our last questions in a quiz, and we will go one after another. So the next question is, which policy approach goes further beyond simple digital inclusion? So giving more people internet access, offering a short course to basic digital skills, combining advanced skills with research infrastructure, mentoring, financing, and pathways to leadership, and giving everyone access to the same chatbot.
Заканчиваю. Нормально?
So you might answer the third option. Great. So now I will skip the slides because I wanted to show that each country has its own program on AI, and you know that in India you have AI for foreign. For example, in Brazil there is also a special program. And the next question of our quiz is, which of these is not the logic behind the BRICS proposals we have just discussed? So I will tell the background. So BRICS is the platform which unites Brazil, Russia, India, China, and South Africa. So I'm here because of this lecture, of course, but also because of summit of BRICS Civil Council, where I am chair for Russia side of the working group on technology. So we designed some proposals, and now you can guess what we decided. So, still 12 seconds. So actually we decided to create joint research. So next question is, because we need to finish this which trend best explains why AI policy is increasingly becoming energy and industrial policy? That AI models require fewer physical resources every year, that AI depends on large-scale computing infrastructure and semiconductor supply chain, that most AI systems now run entirely on mobile phones, and that electricity has little effect on AI development. It is actually connected to the AI thing we already discussed, yes. Okay. Yes, that's true. So thank you for listening to me about AIK. Now, I think it would be the last question. It is about United Nations. You all know this organization. So why still the United Nations is the most important organization for us, for AI governance? Because it developed the world's most powerful AI models, because it directly controls international data centers, because it provides the broadest universal intergovernmental forum, including both major AI powers and states with limited technological capacity, or because it can directly regulate every technological company. So this answer. Yes, true. This is the third answer. Of course, because still, if we talk about this international competition, we have different layers. We have on the state level, we have regional level. For example, you have ASEAN, ASEAN. We have also BRICS. We have African Union. Yes, and the European region, they have their policy. But something unified is only United Nations. Of course, it's not the most effective platform, but still this is the platform that unites all countries. We don't have alternative. So this is the final question about today's lecture. Which statement best captures the central idea of today's lecture? That the first option is that the main goal is to ensure that women become more active users of AI application. Technological sovereignty means reducing international cooperation. Women participation across critical technologies matters for equality, innovation, and the capacity of societies to build and govern their technological future. And the last one, the future of AI will be determined primarily by the fields, the large language models. So all of you replied correctly. So thank you for listening. And before I finish and show you the results of our competition, I have to say that what is really important, I think, for you, for me, and for every woman in technology and for international governance is to understand all of these layers, all of parts of the game, and then to choose which one is the more interesting group to participate, to connect with technology, and then to study, do your best, and then just do the best job in this sphere. And this is the only way for us to influence our future. So here you can see some links to know more about BRICS Expert Council Russia, which I came from. Here you can, I think we have a problem with these slides to scan. Probably I could send the link and we can share with you. There are some reports we also made, they are available in English. And of course, these textbooks that I showed before, I really would be happy if it help you with doing your studies here in Delhi. So yes, this is the QR to our text. Thank you very much. It was a pleasure to talk to you today, to see your attention. Thank you once again to Professor Mehdi, dear colleagues, for having me here. The next lecture will be more interesting than mine, because you will know more about space competition and space race. But for now, I finish and thank you. And if there would be any questions, I will be happy to talk to you afterwards. Thank you. And yes, I forgot. She was the leader. Sorry. So, yes, now I can see the names, but our winner doesn't have the name. No. No. Could you please help me? Yes. I think it's Alicia.
It's Anvita.
No, there, you have to move them. Okay, I will now figure how to. No, they have several ones. Several. So I will now study how to see our leader and tell you after the leader's lecture. Thank you.
Slides.
Ah, here. Yeah.
We really appreciate your time and insights. Now I would like to pleasure to welcome Professor Peter Sir, Professor in the Department of International Entrepreneurship and Design Field of State University of Aerospace Instrumentation and an expert in physics, Russia, expert counsel in the SDI sector. Professor Peter brings valuable expertise at the intersection of international entrepreneurship, science, technology, and global cooperation. Today, he will take us on the inspiring journey from Gagri to Gaganyaan, distant India, and space in the changing world, exploring the remarkable evolution of Russian and space cooperation and the growing role of BRICS in the areas such as human spaceflight, satellite technology, navigation, Earth observation and the scientific research. I'm sure this
Okay.
insight will
Thank you.
give us a broader perspective on how science and technological cooperation can shape the future of international relations. Please join me in warmly welcome Professor Peter Sir. Now I would like to invite I would like to invite Professor Neha Joshina to present a moment. Professor Peter Sir for as a token of our respects and appreciation.
We're proud privilege to have.
Thank you, director. Please participate. Who considers artificial intelligence as a threat? Artificial intelligence already killed half of my lecture. So, already 30 minutes. She got 30 minutes from my speech. But my students are always happy when I use the methodological skills to make my speech shorter. Because reading and I guess will be also happy that I will be quick. I will say a few words about my way. I started with my law degree in St. Petersburg. After that, I worked in the Ministry of Foreign Affairs. I worked 3 years in Paris, in the economical section. That time we had the dual programs with the French side. They used our rockets, Soyuz, to launch the payload to the lower orbit. So we launched European satellites to the lower orbit. After 3 years, I returned back to Moscow State University. With certain relations, I worked for 2 years there. I decided to come back to St. Petersburg, my home. I started to work in the Department of External Relations of my city, and as a professor, I started to work in the St. Petersburg State University of Aerospace and Communication. So I not mentioned that, but I understood that there is a gap, that you get interdisciplinary in the law, international relations, engineering, and that's all. Pretty rough. Why? If you speak with the engineers, they can create very sophisticated things. But for me, it's incredible that they sometimes they don't understand what calculation on the ground means really. And that's the place where it's especially the social life. We can translate from the language of engineers to the language of normal people. In part of the humanitarians. So I started my expertise on this crossroad, this very important, between war, national relations, and space technology. And the other thing just I love space and I like to popularize it, and there are a lot of interesting things, and we will discuss it. Who's this guy? Well, that is louder. Good louder. Who is it? What did she do? If you search in space, and how did he do it? Using what spacecraft? Apollo, American, yes. Who said this? Apollo, another American. Sputnik is just flying there, but you are correct because it was this Soviet mission. It was this Soviet-Indian program of friendship. So we together started our way into space. It was in 1984, 6 years before the first Indian satellite was launched by Soviet rocket the lower orbit. It was constructed in India and launched by Soviet Russia. So it was the first sign that space is a very difficult and a very aggressive dimension, and that we can achieve something in space only in that direction. So I will skip this slide. But for you, after the lecture, maybe we just read this history about the Soviet program Intercosmos. It's very interesting. You can know from this Intercosmos, in the other sources, that the cosmonaut from Afghanistan or from Cuba was before the cosmonaut from France. It's very interesting. Just think.
And yes, of course, he said that India is the best place in the world because he saw it from the space.
Do you know Gagarin? Who is Gagarin? You know what? Gagarin was the first man in space ever. Yuri Gagarin, yes. Which year? A century ago, in the 50s.
But the history starts before.
I will really short. So from the left to the right, for the Soviet Union, for the Russians, space is not just the technology, it's not just the arena of the fighting between the countries. It's the philosophy. The philosophy which started in the end of the 19th century. In the left, it's the philosopher Nikolai Fyodorov. He was from the poor family from the farthest Russian village. And just he started to think that one day the human beings will live forever. If that was his idea. And the earth, the place in the earth, won't be enough for all of us. And we should explore space to find another place to live. Remember, it was 150 years ago. After that, he gave lectures to the second guy. His surname is Tsiolkovsky. He created the theory that the spacecraft must be like the train. All the rockets, even India and Russia, United States, including the normal usage rockets, they are the same. They have the same concept. The first stage, the second stage, it was the idea of Tsiolkovsky. His idea was also about the space lift, which for now is something like science fiction, but probably we'll see it in the lecture. So Nikolai Fyodorov gave the lectures to Tsiolkovsky. But Vygotsky created another theory you can read about the biosphere and so on. So these three guys created the idea that space should be we're colonized, but we should conquer the space as a human being. And the Tsiolkovsky gave lectures to the second guy, to Korolev. Sergei Korolev, he was the creator of the first Soviet robot. So the circle was the encircle. This is the story. First, it was an idea, and then after that, that was an engineered concept. Here's this Sergei Korolev. And the interesting fact, you know, Gagarin, and the real name of the first philosopher was Nikolai Fyodorov. His real surname was also Gagarin. He was Nikolai Gagarin. It's interesting because from Gagarin to Gagarin, and now to your program. So, Korolev created the whole engineering system. It was not only the rocket. He created the industry. He did the factories. He created in the Soviet Union after the revolution. We had almost nothing. We had no factories. We had no theoretical school. So he created the whole system over the idea of Tsiolkovsky and Fyodorov. And that is fully. So Rajesh Sharma couldn't use this to fly, but the signal sent by Sputnik in 1957, it was the signal that idea shaped by mechanical organism to fly to space and so on.
That signal transported into the human presence in 61. That is Yuri Gagarin, the first man in space.
Of course, his famous smile. It was a big victory of Soviet Union at that time. Traveled all over the world. He's the best known Russian all over the world.
After that, it was the good sign that he entered the lower orbit. But the bad was that it started the concurrence between global powers of that time. Who is this?
You know her? It was the first woman in space, Valentina Tereshkova. Now she's in the government of Russia. She's still alive. She works hardly. And how many women were in space now? About 83, if I'm not mistaken. But she was the first.
And she started the exploration of space by women. Who is this? You definitely don't know, but it's Nikolai Leonov. He's famous because of his first he entered first in outer space of the spacecraft. This is the Indian satellite launched with the cooperation with the USSR. And here is the crew with the Rakesh Sharma. The emblem with the name Salut is the emblem of the Intercosmic Program of the Soviet Union. So, with the flight of the Yuri Gagarin, the competition accelerated at cooperation scale. And we will discuss. Oh, not this. When the powers of that time, Soviet Union and the United States, achieved the point where the next step will be mutual destroyed, we decided to collaborate in space especially. There was a special, very famous mission, space mission, which was called Soyuz Apollo. It was a mission where the spacecraft from the United States connected with the spacecraft of the Soviet Union. It was the beginning of the era of cooperation. It was not a long era, but now it's up. But it was also a sign that we can explore space only in cooperation. What happened in the 90s? In the 90s, it was the start of the space commercialization, because before that, the space was only the place for governments. You know, if you ask someone about space, he will tell you that space is very difficult and very expensive. Yes, we saw it. And in the 90s, they decided that the space economy exists. That was the start of space economy. And what do you think? In which sphere you can get money from the space? Huh? Headline. How money? No, I mean, maybe resources, maybe space tourists, maybe something else. No. As 20 years before, and now it's satellite communication, TV translations, communication, and everything else. So the most part, the money of SpaceX comes from the satellite, from the communication, from the internet. The second is the remote sensing of the Earth. When satellite do pictures of the Earth and they sell it. The third is the launch, but to launch something, you have to create the satellite. It couldn't be the resource or the economical resource itself. Space tourism is only 3 to 4%.
when the space started to commercialize, they picture change, the landscape change. What is crucial when you're trying to get money from space? The crucial is the price of the kilo. How expensive is to launch the kilo or the payload to the lower orbit? And what happened in the 2007 or 10? It happened with the famous name of Tesla. He started to use the multi-use rockets. So the usage when you travel from Delhi to Mumbai on the car, it's stupid to destroy your car in the end of the trip. You will use it at the end. That's the way he acted with the rocket. So the rockets, the payload can become cheaper, and you can launch more. With this, he launched the program to. What do you think? How many satellites from SpaceX now? For example, 80. 80. Third one, it's about 10,000. Elon Musk launched now the number of his satellites is more than all we had launched before. So the lower orbit is now overpopulated. I will show you. It looks like this. There is a special website tracking the satellites. About 16 functioning satellites. 10,000 of these 16,000 is SpaceX, and on the lower orbit now, there's about 40,000 of objects. You can read after the speech about the so-called Tesla effect. It's a theory, but it could be our life in the future. It's the theory when one satellite collapses, it will cause a chain reaction. And the lower orbit, we wouldn't use the lower orbit because it will be fully agreed satellites. What will happen if it will happen? What will happen with our life? I arrived here on the group. It was very hot, and there was a traffic jam. And Google told me to tell my friend driver to change the route of the road because Google knew that there is a traffic jam. If the lower orbit collapsed, we couldn't use navigation at all because the GPS system is the satellite. We always talk about the animal, looking in our laptop, and we forget to look up because of satellites, we live our lives like this, like today. Well, the logistics will collapse because all ships need the orientation in the sea and the forecasting of the weather. All of this is made by satellite, by the satellites on the lower orbit. By the way, you know about the International Space Station? Yes? How far is it? That's the quick one. 400, yes, around 400. And the Elon Musk satellites 550. ISS is about from 330 to 400, which changes very orbit sometimes. So if it will happen, our life will really collapse. For the international relations, what's interesting happening now? We are against the regulation. SpaceX is a governmental private company. Private, yes, supported by the government, but private. So, but it's every 15 minutes, the satellites of the private company process the model of every country in the world. Over the India, over Russia, or Iran, or other countries. Who decide when switch on the services or switch off? Who can decide? The private companies. It's not regulated at all. Yes, they must give the rule of the International Communication Union. They should have the frequencies from the countries. But in the case of Iran, sent the court that to stop the usage of the starting on their territory in 2024. Still now, they had no answer. So the terminals work in the usage during the conflicts, Russian knows better than everybody about the using of starting. Who decides? So this is the really gap in regulation. And now we are starting to discuss this on the field of the United Nations, on the field of BRICS countries. So it would be your work to decide it. It's very interesting to solve this problem because the next step of this technology, if you hear about the direct device or direct to cell function. When the satellite can connect your phone directly without the telephone. It started as a test in several countries and it's already working. So, if our government, sorry, with the support of the population, said that no, we should stop this. How can you push the private company to do it? So, this is the gap. And it's very interesting. Another thing which is now seems to be from the sci-fi videos or from the cinema is the explanation of the resources of the celestial bodies, the moon exploration. When I first time heard about it in 2017, I thought something crazy. But now the science moves forward, and there are several types of resources that could be used on the moon. First, which one? It's water. Because the modern rockets use hydrogen as the fuel, and using water you can refuel your rockets on the moon. And now there are also several variants of the regulation of this. So when in 1967 the space law was created, it was all about the countries. Now it's unregulated. You hear about the Artemis Accords in the United States. So this is the one point. The United States they try to make the coalition, and in the part of this document there is the creation of the safety zone on the, for example, on the moon. So if they create their base, they create a safety zone around the base where because of safety you cannot land your rocket or spacecraft. But maybe the instrument of privatization of the celestial body, which is not corresponding with the United Nations, it's also interesting. Why is it interesting? Because India, what did you do? You send your missions on the backside of the moon. You were first, you lead back to do it. And you did it before us because our spacecraft crashed and we didn't succeed to make it work. And you succeeded. Another way for your scientific work is, of course, private space and conservational space. Because here, you're also the leader. India is the leader. Because in 2020, you started the in-space agency, and you've opened the access for private companies in the governmental sector, and you made it very good. Because in Russia, it's not working. Its space is absolutely permanent. And your startups like Skyroot, Google, they are best. And this is also the field where you can work interdisciplinary. I guess 25 minutes is my time because of the AI. Maybe you have some questions about the space, about the time, you know, I finished. No questions. Thank you all for your attention, and if you want, please join our researchers. I don't have my QR code, but if you want, you can track me. Even
I am press secretary.
the newspapers about Indian space, about your startup, and we can be something together. We can collaborate with universities, with your beautiful, respectful university, ICE Space University. So you are always welcome because we've started to collaborate. You saw it century ago. Thank you very much for your attention.
Yes, and the winner is Kavya with 92% right answer. So who is Kavya? Please come here. Here is the small present from the is all our main sightseeing places and also the Emperor, Norashi's, the famous great Emperor room in the palace. So this is for you. Congratulations, and thank you everyone. There were a lot of side questions. Thank you. Maybe you have some questions. I can give you my microphone so you can hear me. Now you're my. They don't have those. Oh, they're tired. So unless we move us to our audiences.
Thank you so much, Dr. Alina ma'am and Professor Peter sir. So I'm invite all of you on stage. There is a one photograph session. So all students come on stage. And how was the lecture? Did you enjoy that? I'll capture all of the emotions on the lecture while clicking the photograph. मैं एक बार photograph session आप आ जाइए. दिन को अरे फिर क्या बोलते हैं
Also, Prophet art hero.
I call it to make the lecture shorter by the methodological skill. And to go Friday evening.
Yeah, it.
My students are always happy to hear that.
Okay.
On stage.